topic of discussion is question bank for semester 3. The subject is SOM and this is for mechanical and automobile engineering. So, for chapter number 1, that is moment of inertia, I have listed no question. For chapter number 2, that is simple stresses and strain, I have listed the theory questions and also the questions which are asked for proof that, or the questions which were asked for derivation. Okay. So as such, here in question bank I have included the theory questions, the numericals where it has been told to derive or prove that. So chapter number 2, simple stresses and strain. The first question, draw stress strain curve for ductile material and explain salient points on it. Define Poisson's ratio. Question number 3, define bulk modulus. Question number 4, derive expression for deformation of uniformly tapering rectangular section bar. Question number 5, a uniformly tapering rod of length L and diameters D1 and D2 is subjected to an axial pull P. Prove that the total extension of the rod is 4PL upon pi capital E D1 into D2. Question number 6. Derive an expression for elongation due to self-weight of bar, or it may be asked, a steel bar diameter D of length L hung rigidly at the top ceiling, determine its deformation due to self-weight. Now, chapter number 3, that is shear force and bending moment in beams. Question number 1, what is sagging and hogging moment in bending moments? Give its sign convention. What are the characteristics of bending moment and what do you mean by point of contraflexure? Establish the relationship between shear force, bending moment and rate of loading in beam. Okay. Now next question for chapter number 3. Okay. So question number 4, draw the shear force and bending moment diagram for a simply supported beam of length L subtended to a clockwise couple M at the center of the beam. Question number 5, draw the SF and BM diagram for beam loaded as shown in figure. So this is the figure where the beam loading has been shown. So here we have to draw SF and BM diagram. Question number 6, a cantilever beam of length L is subjected to uniformly distributed load of small w per unit length for a distance capital L divided by 3 from free end. Draw shear force and bending moment diagrams. Now, chapter number 4. Stresses in beam. Question number 1. State assumption made in simple bending. Question number 2. Derive flexural formula, that is capital M upon capital I is equal to small fb divided by small y is equal to capital E divided by capital R, or it may be given in different notation. Then question number 3, explain beams of uniform strength. Question number 4, a rectangular beam is to be cut from a circular log of diameter D. Find the ratio of breadth to depth for strongest section in bending. Chapter number 5, direct and bending stresses. First, derive an expression for maximum and minimum stresses at the base of the column of rectangular section when it is subjected to load which is eccentric of both axes. Similar question, derive an expression for maximum and minimum stresses at the base of the column of rectangular section when it is subjected to a load which is eccentric of one axis. So question bank for chapter number 6, that is shearing stresses in beam. Only one question, for a rectangular cross section of beam show that the maximum shear stress is 1.5 times the average shear stress. Also draw shear stress distribution diagram. So now that is torsion. State the assumption made in theory of torsion, or it may be asked, give assumption in the analysis of pure torsion. Question number 2, state torsion formula and explain the term involved in it. For a circular shaft, derive torsional formula or equation of torsion, that is capital T divided by capital J is equal to capital G theta divided by small l is equal to tau divided by capital R. Then question number 4, state differences between torque and bending moment. Then chapter number 8. So for chapter number 8, strain energy, only one question, show that the strain energy equation in simple supported beam carrying a UDL W per meter is given by U is equal to W square into L raised to 5 upon 240 E into I. For chapter number 9, deflection of beams, write a short note on Macaulay's method. Now chapter number 10. Chapter number 10, that is thin cylindrical and spherical shells, define hoop stress in thin cylinder, derive the formula for it. Question number 2, define longitudinal stress in thin cylinder, derive the formula for it. Question number 3, derive the expression for change in volume of thin spherical shell with usual notation. Question bank for chapter number 11, columns and studs. Question number 1, what are the assumptions made in the analysis of studs and columns by Euler's buckling theory? What is equivalent length of a column? Give the ratio of equivalent length and actual length of columns with various end conditions. Also write the expression for crippling load P for various end condition. Question number 3, what are the limitations of Euler's formula? So these were the questions from chapter number 1 to chapter number 11. These were asked in earlier years. So these questions are important. Hope you like the video. We will again meet in the next video very soon. Till then, goodbye.